if people are willing to participate, which means the mic is going to be going around. It will be very awkward for me if folks aren't willing to do some answers. So I'm asking you in advance to please, I know it's harder in the big group, but please, when the mic comes around, we'll ask that you participate.
Do you want a mic?
I think so. Okay. About this workshop, Keshav shared that one of the big things that's happening in Nepal at the moment is an expansion of many of the roadways. That the highways are expanding from 2 lanes to 4 lanes. And that, in theory, sounds like a simple thing to do, but it's actually a very, very challenging thing to do in areas that are subject to hazards. Because you have limited space, you've got limited resources, and you have to make tough decisions around what approach are you going to take to doing so. So what we're going to do today here is work through a situation like that together. So the situation is we're going to be a design team, all of us together, and the design that we need to get started on, or our problem that we need to get started on, is we have a main road. It's subject to rockfall and a large landslide. Does this sound like a road in Nepal?
Yes.
Yes, this could be a road in Nepal. We need to expand the road from its current size to accommodate additional traffic. And there have been signs in the last monsoon that the large landslide may be unstable. My experience in Nepal suggests this is something that's quite realistic. I'm hoping that resonates for others as well. So because we're not going to do the writing, I am going to need Alex and Emily's help, or maybe Sneda's help. And we'll ask, instead of writing down, look, Alex is taking his jacket off. You guys can't see it, but he promptly took his jacket off to help us here. So what I will ask, and we'll do this a little bit more on the fly. Ooh, pardon me. Is I need for you to help me. Remember what Alex talked about the first day. Remember what we've just heard. To help define what is our problem and what are our objectives. I'll put it back. So can we have a first volunteer to tell us what's the problem that we're trying to solve here?
Rockfall and landslide.
Rockfall and landslide? Wonderful. Any other problems we have to try and solve here?
Additional traffic.
Yes. Our current road's not able to accommodate the traffic. Wonderful. Any other problems? Yeah, it's seeming like the slope where we know there's a landslide is starting to reactivate. We're getting worried we might lose access to this road. That's wonderful. So that gives us a sense of some of the problems. What can we think about of objectives? What do we want? What do we hope to be able to achieve? Expansion of the road, yes. So we want a road that's going to function with 4 lanes, maybe more.
Stability of slope.
Oh, this is wonderful. Thank you so much for participating. We want to be able to manage the risks. Yes, we want people to be able to use the road safely. We want to be able to reduce costs. I heard one over here, but I didn't see who said it.
Stability of the slope.
That's right. We want the slopes to be stable. Okay, wonderful. This is very good. This is very helpful because it helps us to understand what problem are we trying to solve. We're not trying to solve a major flood. We're trying to specifically think about this particular road corridor, managing rockfall, managing landslides. We want to have folks be able to use the road safely, cars to be able to use the road safely. I'm going to give you some more information now. So this is kind of accurate. You have a problem situation, and now we've got an opportunity that's in front of us. The opportunity is that the Asian Development Bank has said, okay, you've got a real problem. We're committed to being a part of a solution. But there's always caveats, right? It's never a blank check. A blank check means anyway. Okay, good. It translates. Folks' heads are nodding. So what they've said is, we're going to help you, but it must cost no more than $50 million, capital cost, and an important lesson we've talked about here, the operations and maintenance, it must not cost more than $5 million over 50 years, and it must not impact an environmentally sensitive area. So how does this new information add to our problem and our objectives and some of the constraints that we have to work within? Needs to be cost effective, right? We've got to be able to do this for $55 million over the life cycle. What else?
We cannot change the already existing structure or environment of the particular place.
Okay. I think I should clarify this a bit here. And maybe this is less of a Nepal example. Keshav will slap my hand later. But in Canada, we have land that's set aside in parks or land that they've identified that says the animals that are here, the plants that are here, they are very sensitive and you cannot construct in those areas. So I don't know if this translates, but that's what they're saying. If you pick a new road, it can't go through one of those areas. Anything else we would add to our problem statement?
Yeah, I think that applies in Nepal as well. That's why.
Thank you.
Yeah, that's why it took very long time to have the bridge near the across the Rapti River near the Teton National Park. Yes. Still I don't know. Still the road. I'm not sure, but till back few years the road was not paved because of the World Heritage something like that. Even we still have issue with having undergrounds near Guesori or something like that. Yes. So we still have those concerns.
Okay, thank you, Keshav. Okay, so here's our existing route. Who remembers what hazards we have? Rockfall? Wonderful. We've got a rockfall. We've got a large landslide. Now, good news. Another consultant has done part of our job for us. This is very nice when it happens, provided that you trust the other consultant. They have figured out we've got 3 options. So the first option is we mitigate hazards on the existing route. The next option would be that we start on the existing route and we reroute the road for a section. We go around the hazards. And this is maybe a unique situation. We've got 2 alternate options. So we've got a longer one that goes all the way around. So what we're going to do today is try and decide which of these 3 options we'd like to pursue and take into design. There's a caveat at the bottom, which is there is going to be no perfect route. None of these routes is going to be hazard-free. They're all going to cost money to construct. So we're not looking for a perfect answer. We're trying to figure out which one we think might be better. Okay, so I've given you some information. You've got 3 routes. We know the existing road has 2 hazards. What would you like to know about the other 2 routes to help you to decide which one would be the best? How much is it going to cost? Absolutely. What else would you like to know?
Risks of another road.
Risks on the other road. Are the other roads subject to hazards? We know the answer is probably yes. In almost all cases, it's going to be yes. What else would you like to know? I've heard a lot from this side of the room. I don't know this side of the room. Or do you have something you could share? Yes, what geography is it going through? Very important to know. Is it going to be possible? Is it going to cost significantly more? What hazards are they going to run into? What's the geology? Wonderful. What else would we like to know?
Technically feasible.
Is it feasible? Yes. Is it going to be possible? It's another consultant, right? We always have to be careful when we're picking up someone else's work. We have to check, do we trust it? Does this seem feasible?
Operation and maintenance costs.
How much is it going to cost us? Because remember, the ADB said no more than $5 million. Yes, important.
Environmental aspect.
The environmental aspect. The ADB said no going through environmentally sensitive areas.
So when we are talking about the alternative routes, like we would also want to know while constructing the alternative route, is it going to trigger new hazards or not?
Absolutely, yes. Is the road construction itself going to increase the risk? Maybe there's some other communities that are downstream. Maybe there's some pieces of infrastructure. We can't increase the risk to other areas by doing this new construction. That's just moving the risk. We want to manage risk. We want to reduce risk. Okay, I'm going to give you some of that information. Not all of the information that you want, but remember, this is a simple activity. You would do more. So are there hazards along every route? Yes. It's no surprise. There's going to be a hazard along every road. There's no perfect road. How much road do we have to construct? So with our existing road, we don't have to construct any new road. We don't have to bring a new corridor. We just have to expand it. On our shorter route, it's about 2.5 kilometers, and our longer route is 5 kilometers. So it's not inconsequential. Do they go through environmentally sensitive areas? Unfortunately, one of our options does. Are there any cultural landmarks impacted? This is good news. Nothing, none of the routes are affecting cultural landmark areas. And then, of course, the first thing I heard is how much does it cost? We want to know how much it costs. So, to keep the road, remember there's 2 parts to our cost. To keep the road where it is and continue to manage it, it's going to cost us $10 million. To move the road a shorter distance, about $15 million. And to move a road a longer distance, yikes, almost $30 million. So we know all roads are subject to hazards. We've got this road must be closer to a river. It's got 2 flood hazards. This one has rockfall and debris flows. Now, the next question, who can remember? Alex told us that there's 3 parts that we need to know about hazards. It's not enough to know that there's a hazard. What do we need to know? This is so good. I don't know what you said. I'm very convinced, though, that what she said was process type. We've already heard that. The size and intensity, and the likelihood or the probability. Wonderful. So I'll tell you a little bit about our hazards. On our existing route, we already know that. There's rockfall and a large landslide. Our rockfall is about 1,000 cubic meters, so 100 dump trucks to remove it. That probably happens every 10 years. Our large landslide is a million cubic meters, though, so it's really large. On our second route, we've got flood hazards. They occur every 10 to 100 years, and they've got reasonably significant peak discharges. So there's a difference here when you're talking about rockfall versus floods. With rockfall, you're going to talk very much about the volume of rock. When you're talking about floods, debris flows, you're going to also pay a lot of attention to the flow in cubic meters per second. Okay, and then our last route, we've got rockfall, but it's little. It's like 1 dump truck. We know it's going to happen every year, but it's 1 dump truck. It's not even really worth worrying about. We've got a debris flow, 25,000 cubic meters. That's starting to be a problem. That's like 2,500 dump trucks of material coming down at 350 cubic meters per second. That'll be a problem for us. So, just based on that information alone, again, we're kind of collecting information over time. Any preliminary thoughts on mitigating these hazards? Do some of them stand out to you as ones that are going to be a bigger problem than others? Are some of them going to cost more? Is anything else popping out? Silence this time? Last time it was like I couldn't hear what you said. Do you have a brave soul, maybe with a hand, who would?
It might help to just correlate, because it's hard to see even from here
Oh.
where the A, B, C, D fall, so helping
Yeah.
connect the colors.
Yeah, so the purple is your shorter route, the purple route. Thank you, Emily. And this one is our orange route. So pull it around. There's no burning thoughts, that's no problem, we can move forward. This is a lot to build quickly. I'm going to move ahead just because you'll have time to continue to absorb it. Now, because we're short on time, everybody gets the gift of not having to do math, which is wonderful. I will be doing it for you. But you'll remember A and B are on our existing route. B is our large landslide. C and D are on our short route. E and F are on our long route. And each of them have a cost. There's no free risk management here. The capital costs, this is in millions of dollars. So this would be $500,000, this would be $100 million. And then we've got our O&M costs. So what do we do when we've got capital costs and O&M costs? We add them. Wonderful. I'll do it for you. Oh, this was your activity to do it. I'll do it for you. And there's a wide variation. So we're going from $30,000 to $100 million. And this is actually quite realistic. You know, some hazards, we don't have to do a lot. That's what Emily was showing us with Zed Creek. The timber was very effective, very cost effective, totally appropriate. That's not going to work for a 1 million cubic meter landslide. And maybe some of the things that we learned from Alex is that there's going to be situations where we say, we're not going to be able to mitigate that risk. The next thing that we looked at with Alex is it wouldn't make sense to mitigate here and here, right? You're nodding your head at the front here. Why would it not make sense to mitigate this site and then that site? That's exactly right. So it's not about picking which of these hazards we should mitigate. We need a section of road that we can keep open. So we can't look at these costs in isolation. We have to say, how much does it cost to mitigate hazards all the way over or all the way over? So I'll give you that information. I'm saving you some math again. But we've got one corridor staying on the existing road is $100 million, we think. Mitigating hazards on the shorter route is $21 million. Mitigating hazards on the longer route is $6 million. Do we have enough here to make a decision of which one we prefer? Some yes, some no. Some Nepali head shake in the middle. You never really know if it's yes or no. Pardon me? The construction costs are different. Wonderful. Wonderful.
Not only the construction cost, the longer one road has the higher operation cost as well.
Excellent. Very, very, very good. So I'm just breezing through, but what are we missing? The construction costs, the operations, maintenance costs. We have to pull the whole picture together. Okay, so we look at it again. We've got the cost to mitigate the hazards. We've got the cost to move and maintain the roads. I'll do your math.
But what about the capital cost for construction?
So I started this yesterday on my computer, and I was carrying through the capital costs and the O&M costs, and then I decided we have to bring them together for simplicity. In your analysis, it would be very important to be thinking of them as separate design criteria, but I've made a simplification. The first thing, though, okay, so now we have all the information that you're going to get. And now we need to make a decision. So now we need to start weighing the different criteria. Who can remember like the one thing that's really, really important when we're thinking about the criteria?
Life safety.
Life safety is a very important criteria, but when you're thinking about criteria, I tried to make the message the other day, which was, can the criteria live in your head? No. You have to write it down, right? You have to make sure that you're getting it down on paper, documenting exactly how you made the decision, demonstrating, like Alex was saying in the probable failure modes analysis, I can prove I thought about this because you may get asked later. Okay, so decision criteria, the first one everyone thought about, cost. How much money do we have? $55 million. Very good. Which option? It's not viable anymore. Option A. Okay. It's unfortunate. It would be easier in many ways to stay on the existing route, but it doesn't meet our criteria. So, what this helps us to do is say, spending any more money investigating, staying on the same route, is that good value? No. We don't want to spend any more money thinking about the existing route. We have enough to know. And even if, costs, we're never sure on them, right? So if we said you have 55 million and your estimate was 56 million, is it worth investigating? Yes, because we're not totally sure on the costs, right? It might meet the criteria. But when we're at 100 million, when we're twice as high, we can rule it out. We're not going to look at this option anymore. Okay? We have two options. They cost basically the same. So, very good. There's more criteria. There's more criteria. Okay. These are repetitive when you're not doing it there. Does not impact an environmentally sensitive area. We cannot impact an environmentally sensitive area. So, we've already ruled out. We can't do the existing routes. Which other route can we not do? Route A. So, does it make sense to spend any more money on Route A? No. Excellent. So, this is a very quick activity. You have absolutely nailed it. This is, simplified in many respects, but we have chosen a preferred route. We now know that we don't have enough information about this route to design it yet, but what this now helps us is any future information that we collect is going to be on this route so that we can use our money as effectively as possible. You've selected a preferred route. Very well done. I think we have a few minutes to just do a bit of a wrap up here, which is, this was very fast. I absolutely appreciate everyone doing it quickly, and I'm deeply thankful that you didn't make me look out to a quiet room. That would have been very tough. But I do want to bring this back, because although this is simplified, this is a very real process that we apply, and it's actually a process that people get wrong all the time. And what they get wrong is they don't realize the decision points that tell you, I shouldn't spend my money here anymore. Now I need to direct my efforts here. And that's really important when, we need the road to be expanded as quickly as possible because we already know the road's undersized. We've got some suggestions that there's risk because of the landslide. So I'd like to just reinforce over the next couple of minutes, and we'll make it to lunch on time, what can we apply from this example to real-world projects? And if you think I missed anything here, please do speak up to let me know. Okay. You might recall that Alex showed this slide on the very first day, which was the first step in problem solving is to identify the problem. You've practiced that multiple times over the last 2 days, and I think you did it beautifully today, to be very clear about what is it that we're trying to solve here. The next thing, and this one is sometimes actually quite a bit harder, and you see in practice people missing this, is that the first step in decision making is to identify the decision that needs to be made. And we were very clear here, our decision is which route is going to be our preferred alternative to carry forward. Can't overstate how simple this is, but how easy it is to miss that step. So imagine our simple examples when you take them into your real-world projects. You'll see that the practice of having a detailed problem statement will set your project direction. You can think about things like, what is the problem we're trying to solve? What are our objectives? What decision or decisions need to be made? What are key constraints? In this case, the money was coming from ADB, and they were very clear about what they would or would not fund. The next is to identify and document decision criteria. What they will say a lot of times in practice in Canada, and maybe here as well, is if you didn't write it down, you didn't do it. It's not true that you didn't do it, but there's no proof that you did it. So you need to document, we thought about these things, we were very clear, we engaged with people to develop the criteria. Alex showed this slide as well, that we need to seek balance. Remember, there was no perfect route, and that's what's going to happen. There's never going to be a perfect option. We're always going to have to balance the resources, the level of risk, maybe our timeline. So it's not going to always be, it might not always be 3 prongs. It's not always going to be these 3 same things, but being able to document at the beginning, what are my objectives? And knowing that you have to balance those is a very powerful tool to bring into practice. What was not realistic here is this was entirely simple. It was one decision. Quickly, let's make one decision. In reality, there's probably many decisions that have to happen, or complex decisions. So The higher complexity projects that you get, maybe you've got many stakeholders. It's not simple to say, here's 3 objectives. It might be that you have many objectives. What I would say to that, to carry forward, is to do your best to break it into small pieces. So maybe there's a big decision that needs to get made, but you can step back to what's the first decision I have to make? Let's make that one. And also, let's make sure everyone in our big group is trying to make the same decision. I'm not sure if you've had this experience, but many times I have left meetings and thought, we weren't trying to do the same thing in that meeting. You can have that actually extend beyond a meeting to a project if you're not actually trying to make the same decision. So break it up and make it very clear. This is what we're trying to achieve. Here's what the next step after that's going to be. And it's okay sometimes to say, we're not going to do that one yet. We have to do this one first. We thought about our life cycle costs. My friend here, who very correctly noticed that we'd simplified the example perhaps too far, acknowledged that it wasn't just the capital costs. It's not just how much does it cost to build it. How much does it cost to build it and maintain it? So I really hope that you'll take this through. You're probably so sick of seeing this slide and hearing this message, but it is critically important. And I think that may be, yes, I'm going to wrap there. But I will ask, because we have 1 minute, is there anything that I missed? Is there anything that we can take from this hypothetical example and bring it into our practice as engineers and risk managers who need to make decisions about how to manage risk across a wide range of environments?